Okay, so in this class we'll do these two questions. Let's start with third example. 12.10. This we'll find on page 228. So let us go there. Let me read the question for us. Electric iron consumes, let's do slowly so we understand properly, energy at the rate of 840 watt when heating is at the maximum. So there are two cases. So at maximum heating, let us start with that. As we read the question, at maximum heating, this electric iron for ironing cloth, energy at the rate of 840 watt. Now, when I say rupees 100, what do we understand? Yes, we understand because of the unit rupees, we know this is money. Likewise, when we say 840 watt, we must understand that watt is the SI unit of power. So even if they didn't say power of the heat iron is 840, we have to write here power, which is P equal to 840 watt. Question did not tell us, but we know because watt is the unit of power. So the power of this electric iron is 840 watts. Let's go on. When heat is maximum, and 360 watt when heating is minimum. Let's do that second. The voltage in both cases is 220 volts. So here, let's put P1, okay? And then voltage means potential difference only. Voltage here, V. Okay, V is equal to 220 volts. P is V, PV are there. So we're going to relate to this here. PV, all this. Okay, you're going to use these formulas. Now, what are the current and resistance in each of these two cases? Means case one, this one. So current is, in this case, let us put current I1. What is the current? And what is the resistance of the heater at maximum heating, R1? These two we have to find. Just a question of now, you have no P and V, IR we have to find out. Which is the formula? 7, 8, 9, like that. That is the only process we need to learn how to pick the right formula. So let us check now. To find I, maybe we can start PVI. Any formula related to that? Yes, PVI. So we can use formula 8 to find out I, because we already know P 840 watt, V 220 volts. See, since we know by the famous power equation P equal to V into I, which means I1 here and P1 because we're using 1 there. So that will imply here we want to find I1 question mark. So put it, don't shift, and shift this V means into, will go to the denominator. So here P1 is, here let us do 840 watt divided by, everything is now in the same system of unit. We have to make sure we didn't discuss because everything is already in SI unit. Okay, V is here 220 volt. So this is the current. Now we can cancel this and this, and we can cancel 4 2s are 8, 4 1s are 4. 4 1 go 2 4s are 8, 2 2s are 4, 11. So you're going to get here 42 by 11 ampere, which is I1. So that will be 42 by 11. 11 4 is 44 is too much, so 3 33. Then here 9.088. Then 2 0 because of the point. 1s are 11. Then 9 remainder 0. Third place usually we go, so let's go. Then we're going to get here 3.818 ampere approximately I1. But since we usually write only up to second place 3.8, and if third place is 5 or more than 5, second place of decimal will increase by 1. So 1 plus 1 2. This much current is flowing in the first case, first answer. But we need to find R1 also. So let us go and do that now. Now in order to find R1, you can use two formulas here. I square R. I because we already have I. Then P we already have. So we can use this also. No harm. But I prefer another one, this one. Because if you use this to find R, P is equal to I into square R, or use this one, P equal to V square by R, because in this Now the situation is such that we can use any of these two to find R, because they're asking R next. Both will give you same answer, but I prefer this because this is already in decimal, that's why. So go to 10 now. Since again next step, P equal to V square by R. Why did we use this? Because we know P and then this R will go up if you shift. Now we use this because R, so this is R1, P1. See here, P1, R1. So R1 will be V square by P1. We use this because we consciously we know that V is already there here, 220, and P is also there. That's why we use that. We could have used this also because I is also now available. Okay, same answer you will get actually. So here, that will be V square means 220 volt into 220 volt. Why? Because this is V square, so 2 times the same number will appear. P1 is only one time 840 watt. That is your resistance. So 0, 0 cancel. 2 4s are 8, 2 2. 2 into 11. 2 2s are 4, 1. 11. So 11 11s are 121. And 1 0 here, don't forget, divided by 21. And SI unit of resistance is volt square by watt is ohms. SI unit of. Since we're using SI system, they're very easy. Will come out in SI unit resistance also. So we have to divide this 1 2 1 0 divided by 21. Okay, so let us go and do that. 21 is 1210, right? So 6 1s are 6, 2 months, so 5 will go. I think 5 1s are 5, 2s are 10. So 1 borrowed from here, so 11 minus 5 is 6. 1 is gone, so 1 only left, and 0. 6 will go. 6 1s are 6, 6 2s are 12. 7 will go. I think 7 1s are 7, 7 2s are 14. Yes. 3 5 minus 4 1 and point 0. Then 21 6 are, so this is 4 now. 0 1s are 21, and 10 minus 1 9. Then 3 minus 2 1, so point means I can put 0 here. Then 9 1s are 9. Yeah, so 9 is 57.619 approximately. So we're going to get a value of equal to 57.619 ohms. We went to third place, so we can take approximation 57.6. Third place is 5 or more than 5, then second place of decimal will increase. So resistance, the maximum heating is approximately 57.62 ohms, and the current flowing in that same case 3.8. So this double dash, these are the two answers for the resistance and the current. Now let us go to next one. At minimum heating, second case, like when you coil turn this one, the adjuster in the iron, heat increase decrease. So when they put at maximum heat, this is the case. When they put a minimum, there's another case. So at minimum heating, the power will decrease, right? So P2 is now 360 watt. Same style of doing, so I'm just putting that. Then voltage, they're using the same electricity supply, so same voltage there, 220 volts from the department, electricity department. And current will be different this time, so current and resistance also will change. So we need to find those two. So same thing. So we write here P2 equal to V into I2. So let us do that. Write it after there. I hope you're getting right. Now next, that gives you, we're trying to find I2. So P2, same style as we did for case 1, nothing different by V. So we can go faster. I think P2 is this time 360 watt divided by voltage is 220. Volt is the I2. So 0 0 cancel, 2 into 11, 2 1s are 2, 2 8s are 16. So 18 is divided by 11 1s are 11, 7 remainder, 0.0, 6 are 66, 4 0, 3s are 33, 7 0, 6 66. Up to third place we usually will go. So your answer is 1.636, and current SI unit is ampere. Everything is in SI watt and volt. So watt by volt is ampere. SI unit of current is ampere. At least know the SI unit of each physical quantity. Okay, so this is your first. Next step, that will be equal to I2 will be equal to 1.64 ampere, because third place is 5 or more than 5. This will increase by 1. So current in the second case is 1.64. Then similarly, this time P2 like this. So this will become 2. This is 2. That's the only difference. And here 2. I won't be explaining because you already know from the case 1 how we have done this. So just write it up to there. Okay, now that will be equal to V is 220, so V square will be 220 volt into 220 volt 2 times divided by P2 in this case is 360 watt. So 0, 0 cancel, 2 1s are 2, 8s are 16, 2 into 11, 2 9s are 18, 2 1s are 2, 2 1s are 2, and 0. 11 into 11, 121, and 0. Divided by 9, and SI unit of resistance we know is ohms, which means volt square by watt is ohms. So we divide these two, and when we divide, 1210 is divided by 9. 1s are 9, 3 in hand, and 1. 3s are 27, and 30, 31, 4 remainder, and 0. 9 4s are 36, 4 remainder, so point, because no more digit. 4s are 36, again 4 remainder, so same number is repeating, so 4, 36, again 4, 0. Up to third place you can go like that. So we're going to get approximately 134.444 ohms, which is 134.4. Third place is less than 5, so this second place will not change this time. Approximately 134.44 ohms in the minimum heating. So there are two answers in the second case. The two answers in the first case we have already done. I hope you're getting it right. So it's a question of reading the question carefully. What are the given ones? What do we need to find out? So which formula, 7, 8, 9, 10, 11, 12, which one? It's a process of doing that. As you practice like that, it's not so hard. Okay. One more question before we end this part. So let's go to the next part. Example 12.11, page 228. Okay. Let me read the question for us. 12.11, page 228 textbook. 100 joules of heat is produced each second in a 4 ohm resistor. Find the potential difference across the header. So we can do it like this also. Since 100 joules of heat is produced, same sentence of the question also you can use. Produce each, the word each means what? Yeah, 1 each second means time each second in a 4 ohm resistance, in a 4 ohm resistance. So here we can clearly see by the unit, joule is the SI unit of work or energy. So they're asking us what is it? Potential difference. So potential difference is, we know V. Question mark is the potential difference we need to find. Then here joule is energy, so E, or heat, whatever they're putting. So energy or heat is 100 joules. This is the heat generated by the process of heating for each second means time. So 1 second, each means 1 second. This 1 second is the time. This is given. And ohm we know is resistance, capital R. The capital R signifies ohms, resistance of 4 ohms. So V, E, and T are given. We need to find V. So let us see a formula which can connect RTV, RTV, RTV. Here, see. Here. But before that, we can just do like this. RTV. So you have to find out the this one RTV. Since here E is equal to 100 joules, since given to us, like this also we can do, see here. Then look at the formula E which matches our purpose to find V. If you use this here, V squared T by R in place of E, in place of this E, then V we have to find, then T, R already there, see, T and R. So we can use that formula number 14. Replace the E here, this E by this one, V squared T by R. Then we're going to get 100 joules. Because we know that E is equal to V squared T by R. So shift the rest to get the value. We want the V square, so don't move that. Then 100 joules into, then this R will go up. And this T will come down. Like this also we can do. Then we can do slowly. As we go on doing, that implies V square will be equal to 100 joules, do slowly, into R, 4 ohms. Everything is in SI unit, so we don't have to worry. SI unit of time is second. SI unit of energy is joules. Everything is in SI unit, so that's fine. Okay, so time is here 1 second, so we write here 1 second. Then here V will be equal to, now we know V is equal to, then square remove means square root will come. Yeah, square root. And do like this. Then 100 we can write as 10 into 10. We know that, right? 10 into 10, 100. Then into 4 we can write 2 into 2. And the SI unit of potential difference we know is volts. So we can just write joules into ohm by second is volt. We don't even have to bother SI unit of what is this. Just put it there. Then in a square root, double couple number will come as single, and double number will come as single. Then here will be, sorry, V square. So this root need not cover up to number only, and then you can just put without the root volt. If you put root over this one, we have to put V square. Okay, so the 10 twos are 20 volt is the potential difference. Therefore potential difference V is equal to 20 volts. That's our answer. So these are the 4 questions. Now you can give the test. I hope you're getting it. Better memorize all these formulas serially and keep it thoroughly memorized. It will make it so easy for you. Okay.